Good morning, boys and girls. This week, we're going to be working on equivalent fractions. So if you remember last week, we worked on comparing fractions and we used models to compare them, meaning fraction strips or circles. And we also used number lines to compare fractions to find which ones were bigger and which ones were smaller. Well, this week, we're going to generate equivalent fractions. So equivalent means equal. If you look at the word equivalent here, you'll see that almost looks like the base word in there is very similar to equal, and that's what it means, equal fractions. Fractions that name the same amount, okay, or have the same value. So when we find equivalent fractions, just like with comparing fractions, I would never have you do it just by looking at two fractions. We would always draw some kind of a picture with fraction strips or fraction models, or we would use number lines. Well, today our focus or our learning objective is going to be using models to generate equivalent fractions. So I'm going to think out loud here. If you don't have this paper handy, you should get it. It's the one that says equivalent fractions, and it says guided instruction for Tuesday 5/12. Okay. Hopefully you have that in front of you. We're going to read the directions. Part 1 says shade the models to find equivalent fractions. So the first model is already shaded, and there are 3 equal parts, 1, 2, 3. 2 are shaded, so the fraction shaded is 2/3. And hopefully your work with fractions so far to date makes that pretty easy for you identifying that fraction. Well, now we have to find an equivalent fraction. So I'm going to get my shading tool here. And you might want to just use your pencil to lightly shade, but I am going to shade to get the same amount. So I'm going to start with just shading one part. That certainly is not equivalent to 2/3. So 1/6, I guess we could compare them. We would say it's less than 2/3. I'm going to shade another one. And now I've got 2/6 shaded. That's still not the same as the 2/3. So I'm going to shade another one. Now I've got 3/6 shaded. Well, when I look at this, it goes beyond the halfway point. And so I'm going to shade one more. And now when I look at those, I feel like the same amount of this half circle is shaded as in the first one. So I have found my equivalent fraction just by shading one part at a time. And now I'm going to come over here and I'm going to write 2/3 is equal to, well, how many 6 is that? Remember, we count 1/6, 2/6, 3/6, 4/6. 2/3 is equal to 4/6. Okay, very good. Let's see. Let's go on to the next one. Okay, we have a rectangle here. It's kind of drawn vertically up and down. And you can see in our first shape, 1/2 is shaded. So 1 out of 2 parts is shaded. Now I'm going to come over here again with my drawing tool. And I'm going to shade until I get the same amount. I'm going to shade one part. And that is not shaded the same. So I'll shade another one. And now, bingo, it looks like I have the same amount shaded in each of my models or in each of my rectangles. So I can say 1/2 is equal to how many fourths? Well, it's 1/4, 2/4. So 1/2 is equal to 2/4. Okay. And then my last one, this is eighths. And how do I know it's eighths? Because they're 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So again, I'm going to start shading until I get the same amount shaded in this one. So I'll shade 1, that's not going to do it. 2, still not enough shaded. 3, getting close, but not enough shaded. If I shade one more, man, that looks pretty good. I'd say I have the same amount shaded in my last rectangle now. So how many eighths is that? Well, if I count them, it would be 1, 2, 3, 4 eighths. Now, what I want you to do here is look at the pattern when we look at our equivalent fractions, okay? When we go from 2/3 to 4/6, what happened to our numerator? Our numerator doubled, didn't it? It went from 2 to 4. And the same thing happened to our denominator. Our denominator also doubled. It went from 3 to 6. So one way you can find equivalent fractions is just by doubling the number of parts you have in your model. So we went from 3 parts. We split each one in half. We got 6 parts. And then we would have shaded more or double the number of parts just to fill in the same amount. When we look over here, see if the same thing happened again. We went from 1/2 to 2/4, and what happened? Our 1 doubled to 2, and our denominator of 2 doubled to 4. When we went from 2/4 to 4/8, what happened? Our numerator 2 doubled again to get to 4, and our denominator 4 doubled again to get to 8. Some people might show you that you could do this, 2/3 and multiply both the top and the bottom by 2. So I can multiply my top by 2. So 2 times 2 equals 4. And the same thing for my denominator, 3 times 2 equals 6. So that's another way to find equivalent fractions, is just by multiplying your numerator and denominator by the same number. So now let's come down here, and part 2 says, write the fraction that names the shaded part of each circle. So there are 5 circles there. They're all split into different units. I'm going to give you a couple minutes to write those fractions there. All right, hopefully you've had enough time. So the first circle is divided into 4 equal parts. That's fourths, and 1/4, 2/4, 3/4 are shaded. So the shaded part is 3/4. I bet y'all got that right. The second circle is divided into 3 equal parts. 3 equal parts makes thirds, and then I would count 1/3, 2/3 are shaded. So the shaded part is 2/3. The third circle is divided into 2 equal parts. 2 equal parts means halves. And so 1 is shaded, so that would be 1/2 is shaded. My next circle is divided into 1, 2, 3, 4, 5, 6 equal parts. That means 6. And if I count the ones shaded to be 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Remember how I said you should always dress up your numbers when you count? Because if you just count 5 and don't dress up your number, then sometimes you get confused about how to write the fraction. Okay? And then the last one, if we count 1, 2, 3, 4, 5, 6, 7, 8, we have 8 equal parts, and 1/8, 2/8, 3/8, 4/8, 5/8, 6/8 are shaded, so we would write 6/8. Okay, using these models, the next question asks which 2 fractions above are equivalent. Remember, equivalent means equal, have the same value, have the same amount shaded. So I'm going to kind of look at these and see if I can eliminate any of them. Well, I know that none of them have this much white space, so I'm going to cross that one out. Okay, this one has more white space than that. It has more white space than this. And it looks like it has more white space than that. So I'm going to cross that one out. This one is less than this. And if I compare it to the first one, it is also less than this. So I would say this one doesn't match any either. But boy, when I look at how much of this is shaded and how much of this is shaded, it looks like the exact same amount. They both have the same amount that is left unshaded. Sometimes it's easier for you to look at the unshaded part as well. So when I look at these, it looks like 3/4 has the same amount shaded as 6/8. So which 2 fractions above are equivalent? 3/4 and 6/8. Okay, and let's see, why are they equivalent? Well, we just took our 3/4 and what did we do? We divided each fourth in half, so we doubled the number of parts. So we went from 4 equal parts, boys and girls, to 8 equal parts. And that's exactly what you see when you come to the last model. Okay, and then when we look at the number shaded, well, 1, 2, 3, 4, 5, 6/8 were shaded, just like in this one, 6/8 were shaded. So that's why 3/4 and 6/8 are equivalent fractions. If you are asked to find an equivalent fraction for a given model, a good thing to do is draw the exact same thing and split each part in half. In other words, just double the number of your parts, double your fractional units, and you will be able to find an equivalent fraction. Okay, let's go to the bottom of the page. I think we have one more section. And this is exactly what we're going to do in number 3. Part 3, draw a line to divide the first square into 2 equal parts and shade 1/2 of the square. Then draw lines to divide the second square into 4 equal parts and shade 1/2 of the square. So the very first thing I'm going to do is I'm going to draw a line to divide this in half. Try the best to make them equal parts. All right, and then I have to shade half of it. So I'm going to get my shading tool here. And I'm going to shade half of this. So I have 1/2 shaded here. Okay, now it says draw lines to divide the second square into 4 equal parts. So the first thing I'm going to do, just like I did before, is divide it in half. And then remember what I said, if you're looking for an equivalent fraction, you can just divide your parts in half again to double them. So a couple ways you can do it. I'm going to choose to do mine like this. Okay, and then I have to shade half of that square. I'm going to get my shading tool here. And I will shade this part and this part. Now I've shaded half. And so what are my equivalent fractions? Well, if I write my fractions by each one, you know, Mrs. Ridd, I like to show my work and show my thinking. This is 1/2, right? And this would be 1/4 because there's 4 equal parts. And this would also be 1/4. It says write an equivalent fraction statement shown by the squares above. So what they mean by an equivalent fraction statement is kind of like a number sentence. So I have 1/2 on this side is equal to 2/4 on this side, 1/4, 2/4, and those are equivalent fractions. Once again, if you see the pattern that's happening with your numerator and your denominator, your 1 doubled to 2 and your 2 doubled to 4. It was like you multiplied both the denominator and numerator by 2. And that, boys and girls, is equivalent fractions. So what I'm going to do here is I'm going to bring up just the whiteboard and show you from scratch. If you want to grab a piece of paper, I'm going to show you from scratch how you can make an equivalent fraction on your own. All right. So I've got my whiteboard here. Hopefully you have a piece of blank paper. You can use the back of your worksheet that you just were working on. Okay. And I am going to draw. I like to use fraction strips. So I'm going to draw one fraction strip. And then the most important thing is making sure your strips are the same size. So there's one fraction strip, and I'm going to draw another one right below it. And I'm going to try my best to make sure that it is the same size. Stacking them is the best way to ensure this. You don't want it to be bigger. You don't want it to be smaller. So I'd say those look pretty good. Why don't you go ahead and try that? And let's say you're trying to find a fraction equivalent to 2/3. So let's divide our first fraction strip into thirds. So that means 3 equal parts. And remember, if you need to erase because your parts aren't the same size, like I'm already looking at mine and thinking, oh man, I don't think mine are really the same size. So I'm going to erase and do that over again. Better to make them equal. I'm going to try that again. Right here. And then right here. I feel a little bit better about those. All right. And I'm going to go ahead and write 1/3 in each one of those. 1/3, 1/3, 1/3. You can go ahead and do the same. Identifying how big each part is. And remember, I said we're going to shade 2/3. So we want to show 2/3 on this first number line. So I'm going to get my shading tool. And I'm going to shade 1/3. And then I'm going to shade 2/3. All right, now I feel pretty good that I have 2/3 shaded. So your goal, your objective is to find a fraction equivalent to 2/3. So I'm going to come down to my second model, and I'm going to make thirds again. And so I'm going to make them the exact same spots, my lines. So there are my thirds. Okay. Well, if I shade 2 of those, I've got 2/3 again. That's not really an equivalent fraction. It's the exact same fraction. But what can I do? Well, if you think about the practice we've already had, we doubled our number of parts. And we've done this from day one when we would fold our fraction strips. Remember, we made thirds and we folded the fraction strip in half. When we opened it up, our number of parts had doubled into 6. So that's exactly what we're going to do here. We're going to split each one of our thirds in half with more lines. Oops. Well, I don't know what happened to my line. There we go. So go ahead and split your new model in half. And now instead of 3 equal parts or thirds, let's count them 1, 2, 3, 4, 5, 6. I have 6 equal parts or sixths. And I'm going to go ahead and label each one of those with a 1/6. And why don't you do the same on your paper? Okay, now I've got each one labeled with the appropriate fraction. And now I'm going to start shading until I get a fraction equivalent to 2/3. So I'm going to grab my shading tool here and I'm going to shade 1. Well, that certainly is not the same amount shaded. Even if I shade 2, that's not the same amount shaded. If I shade 3, I'm getting closer, but I still don't have the same amount shaded. But look at this. If I shade 4, bingo, I've got the exact same amount shaded. And how can I tell? Well, look at this. When I draw my line here, they're in the exact same spot. So I can say that 2/3 is equivalent to 1/6, 2/6, 3/6, 4/6. 2/3 is equivalent to 4/6. And I can write that as an equality, kind of like in a number sentence. And I have to use a slash, but 2/3 is equal to 4/6. And again, what did we do? We doubled both the numerator and the denominator. So if I show you 2/3 is equal to 4/6, what did we do? We multiplied the top times 2 to get 4, and we multiplied the denominator or the bottom by 2 to get 6. So that's another way to generate an equivalent fraction. I'd like you to start with the models and the pictures because that cements the concept more in your mind than just doing this mathematical expression. So the pictures, once again, are really, really important for us developing a conceptual understanding of equivalent fractions. Okay, boys and girls, so you have an independent page to do today, and there's also a YouTube video that you can watch for reinforcement, and you will find that YouTube video on my webpage. And I'm also going to put a key for the independent practice on my webpage too, so you can check your work. Remember, always, always important to check your work with my YouTube videos or by coming to a Zoom call, because I don't want you practicing wrong and leaving wrong ideas in your head. Okay, so have a good day today, boys and girls, and thank you so much for joining me today.